Factoring trinomials in your not-so-easy form means that there's a number in front of your x squared. So we have a number a x squared plus bx plus c. We can no longer just pick two numbers that multiply to c and add to b, because there's going to be a number in front of your x here in your parentheses, and you have to decide, okay, how is that going to manipulate your outside and your inside? This is going to take some getting used to and a lot of practice. You get good at factoring if you practice it a lot. Practice, practice, practice. See how the numbers form. If you're not so sure about the factoring, go back to foiling in the last chapter and practice that, some of the uglier foiling ones, so that you can see where the numbers come from. There are some methods in your textbook about using all these different combinations to come up with your middle term, or try to separate it into 4 terms to do grouping. I don't need you to do any of that. For me, it was easiest just to guess and check. And as you do a bunch of these and you start looking at the numbers and feeling the numbers and seeing how they work together, you'll be able to come up with your answers a little bit faster. Let's go through some examples. Our first example is going to be 2x squared plus 9x plus 10. You see that we now have a number in front of the x squared that's going to affect our foiling and our checking of this. Go through the same steps though to get your first terms. What times what would give you 2x squared? Instead of it just being x and x, we need to take that 2 into consideration as well. The way that we get a 2x squared is 2 times 1. So 2x times 1x would give me a 2x squared. Now we go on and we do our same type of thought process as we did before. I need 2 numbers that multiply to 10, but the number that's over here, when we do your outside, is taken times 2. So this one's doubled in this problem because of the 2. And then you'll be adding it to whatever your inside is. Well, the factors of 10 are 1 and 10 and 2 and 5. We know we can do something with our signs. This sign, if you recall, because it's positive, tells us that both of our signs in the binomials will be the same, because either a positive times a positive is positive, or a negative times a negative is positive. So then, since it's the same, we follow the sign on B. That rule has not changed for the harder type of trinomials. Since this is plus, both of my signs are going to be positive. So we're adding numbers together. That makes it a little bit easier. So now my choices once again for 10 are 1 and 10 or 2 and 5. If I put the 5 over here, 5 times 2 is 10. And then I have to add more to it. I'm not going to be able to get 9, as the 5 over here would already make it larger than 9 when I do my outside. So I'm not going to put the 5 over here. If I put the 10 over here for 10 and 1, I have the same situation. 10 times 2 is 20. That's way more than my 9. If I put it 1 and 10, well, inside here I already have 10x. So it's not going to be a 1 and 10 combination. Usually it's not. That's the little hint. When you have 2 choices of factors, 1 and 10, 2 and 5, most likely it's not going to be the 1 and whatever your number is. The exceptions to that is when 4 comes into play. 1 times 4 is used just as often, if not more so, than 2 times 2. But pretty much in all other numbers, if you have 1 in the number and a different pair, try the different pair first. So we said that the 5 is not going to go over here, because that would make 5 times 2 and make it too much. So let's put the 2 here and the 5 here, and see what happens when you FOIL it. Notice how I just mentally went through my combinations to see that, hey, I can't use a lot of those. So here I have 4x, and here I have 5x, and 5x plus 4x is 9x. That's what I was looking for. So this is my factored form of this trinomial. Here's another trinomial. Once again, the first thing that we want to look for is a greatest common factor. Is there a greatest common factor among the 3 terms here? 3 does not go into a 5, 5 does not go into 12. No, there's no greatest common factor. Here's a hint. If there's no greatest common factor in the original problem, there won't be a greatest common factor in your factored form. Maybe I should write that down. Here we go. If there's no greatest common factor in the original polynomial, whether it's a trinomial, binomial, or something bigger, then there will be no greatest common factor in any of the factors when you're in factored form. So the little binomials will not have a greatest common factor in it. That can help you eliminate a lot of your options or your choices when you're guessing and checking for this harder kind of trinomials. So keep that in mind. If there's no greatest common factor in your original problem, there's not going to be a greatest common factor in any of your factors later on. Let's go back to that problem. Here I have 3x squared minus 5x minus 12. So let's make our two sets of parentheses. I'm going to go through and show some more thought process as we go through this one. Okay? Once again, to give us a 3x squared, I need 3x times x. Now in this case, I have a minus 12. That means that one of my signs will be positive and one of them will be negative. I don't know which one's going to go where. I'm just going to throw in a positive and a negative and hope for the best. I guess we'll do negative and then a positive. Now, the nice thing is, when I do my FOIL to check, my outside, my insides, if I get a positive 5x instead of a negative 5x, all that means is my signs need to switch around. Okay? If I do my outside and my insides and I get the right number up here but the wrong sign, just means I need to switch my signs around. So let's go through and list all of my options for 12. I could use 1 times 12. I can use 2 times 6. I can use 3 times 4. Now I'm going to go through, even though I have these nice little markers, and see what I can and can't put in there. Now, as I stated before in the last example, chances are it's not going to be 1 times 12. So I'm not even going to choose that right away. If my other options don't work, then I can go back to that. But most likely it's not going to be 1 times 12. So I'm not even going to use that one right now. So I'm going to go to 2 times 6 and see if that works for me. Now, if I put the 6 first, notice here, I would have a greatest common factor of 3. Now, I would be able to pull that out. But as I just stated before, if there's not a greatest common factor in your original problem, there's not going to be a greatest common factor in either one or the other of your factors. Because remember, when we're in factored form, this is equivalent to your original problem. If there's a greatest common factor here that you could then pull out, that's not the same as what our original problem is, because the original problem does not have a greatest common factor. So that tells me that I cannot put a 6 there, because then I would have a greatest common factor. And since I don't have one up here, I'm not suddenly going to have one down here. So that takes care of one of my choices. So I'm going to make that into the 2 instead and put the 6 over here. And now I FOIL the check. Once again, I don't have to do the F of FOIL because I put 3x and x in there to get me 3x squared. I don't have to do the L of FOIL because I chose a -2 and a 6 to get me the -12. I just need to check outside and inside. So outside gives me 18x. Ooh, that's big. Inside I have -2x. -2x plus 18x is 16x. I'm looking for a -5. So that tells me that this is wrong. So let me try another pair. As I stated before, I can't put this in the other order of a 6 and a 2, so that option is completely out. So I have to go back to my 3 and 4. Now, if I put 3 in first, once again, I would have a greatest common factor of 3, and I can't have that. So I've got to try my 4 first and then my 3. Now I do my outside and my insides to see if I get my negative 5x. Outside here, positive times a positive will give me a positive 9x. Inside I have a negative 4x. Negative 4x plus 9x is 5x. But it's positive because 9 is positive. However, in my problem, I need a negative 5x. So I have the right numbers here, but I have the wrong signs. Just have to switch the signs. So the positive is going to go on this side, and the negative is going to be on that side. Now let me double check to see so I can prove to myself that I have the right answer. 3x times the negative 3 is a negative 9x. Positive 4 times positive x is a positive 4x. If I have $4 and I take away $9, now I'm suddenly $5 in the hole. That gives me my negative 5x. So the answer to factoring 3x squared minus 5x minus 12 is 3x plus 4 times x minus 3. I hope that that helps you with your more difficult types of trinomials. Like I said, make sure that you practice them a lot. And always look to see if you have a greatest common factor that you can factor out first. If you don't in the original, then you're not going to have one later. So that's going to eliminate some of your options for you and make it a little bit easier to go through the remaining options. Practice a lot of them. Foil to check. There's no reason to get factoring wrong, as you can always foil to check. Now, we'll finish up this by going through a video on why do I need a factor anyway?